So today we are joined by two amazing speakers from Verizon Media, also Yahoo. So Joe heads the team that provides key value storage and messaging systems for all of Verizon Media. Joe has led the development and operation of multiple large-scale distributed systems, including Pulsar, while at Yahoo. Prior to joining Yahoo, Joe was the architect for database kernel storage and recovery at Sybase. He is a member of the PMC of Apache Pulsar. Joe is well-versed in the development of Pulsar from its very inception, so very, very early days, all the way to its growing pains to a large-scale system and operating at scale in production. Ludwig, who is also joining us today with his amazing Pulsar Summit background, he started at Verizon Media in 2007 when it was still Yahoo and has served as operations lead for its PubSub messaging platform since 2013. Prior to that, he has supported Verizon Media's geo-replicated NoSQL data store and login and registration platforms. Ludwig, Joe, welcome. Thank you so much for making the time today. I'm going to go ahead and mute myself and hand it over to you.
Good morning, everyone. So we're going to cover some of the path which Pulsar took to get where it is in today's presentation. Originally it started as an internal project within Yahoo, and it went through a lot of changes before it reached where it is. So what you're going to see today is the history and more some of the growing pains as we went through this exercise. And most of the things are just past history. They may not apply today anymore, but it's still interesting to know what are all the problems we encountered and how we got through it to get where we are today. So I head the team that runs Pulsar at Verizon Media. I also led the team that originally built Pulsar within Yahoo. So a lot of experience going through that exercise. And Ludwig,
I'm Ludwig Pummer. I'm a principal production engineer at Verizon Media. I'll talk later.
Yeah, Ludwig is also one of the key people who worked on it from the very beginning of Pulsar, about more concerned about its operational aspects as we built it up. Next. So today we are going to cover some of the use cases for which we are using Pulsar. In very brief, we had a detailed presentation yesterday about how we scaled up throughput and all those things. So we are not going to cover that today. How we provision, what is our model, and how the hardware has evolved and how Pulsar has evolved along with it. Our production experience in dealing with some of the issues and how we understand them, and some nitty-gritty details about how to run such a system at scale and keep our SLAs up to what we promise to our users. So Pulsar is operated as a hosted service. It's in a private cloud service within Verizon Media. And it is deployed across 6 data centers in the world. We fully replicate across all of them in fully meshed. And it is backing a lot of business critical use cases within Yahoo. So it is an extremely available and low latency system. Other low latency systems are built on top of Pulsar, using Pulsar as the messaging bus. One of the key trade-offs made in the design of Pulsar is that write availability is very important, and the design actually reflects that, that we maintain write availability at all costs. The main use cases we use it for is, server-to-server messaging. Mostly a lot of applications talk to each other through this bus. As a persistent buffer queue, between pipelines and for streaming data. And as I said before, as a message bus for other low latency systems which have stringent latency and durability requirements. These are basically storage systems, databases and object storage, other systems that requires messages to be, sent with guaranteed delivery and with ordering. So those are, some of the use cases we cover in Verizon Media with Pulsar. And now I'll hand it over to Ludwig, to cover the intricacies about, the growth and operating details and the pains we went through, to get where we are today.
Thank you,
Over
Joe.
to you, Ludwig.
Yep. So here you can see the growth of Pulsar at Verizon Media over the years. When we say RPS here, that means steady state dispatch rate, not backlog reads. So we first launched in production in 2015 with Yahoo Finance as the first tenant. In 2016, we added more critical use cases. We actually launched 2 environments. The first one is for Peanuts, aka Sherpa. That's Verizon Media's geo-replicated NoSQL data store, about which you can find many research papers, so I'm not really going to say any more about it. The environment for Peanuts is responsible for the vast majority of that 1.4 million topic count. The other environment is multi-tenant and serves all of the other users of Pulsar at Verizon Media. In the 4 years since, we've onboarded significantly more tenants to the multi-tenant environment. The Peanuts environment has actually grown to be 2 clusters per data center and responsible for all but 50,000 topics of that 2.8 million, and about half the publishes and dispatches. So what did it take to grow? Scaling up has been pretty much as easy as adding servers. The only effort is, at server setup. It doesn't really take any more extra effort to manage 50 brokers or bookies than it did 5. When you add new brokers, they get used as soon as load shedding puts traffic on them or another broker restarts, like during deployment. When you add new bookies, you can see rights within minutes. Usually within an hour, it'll have an equal share of rights to the rest of the cluster. So what does massively more topic mean? Really, it depends on what's your acceptable time to recover from a cold start situation, like a Zookeeper quorum loss that exceeds the session timeout. So the cold start startup time is a function of your Zookeeper write throughput and how many topics and subscriptions you have to recover. At 1 million topics, we saw cold start recovery take about 30 minutes until the last topic loaded and traffic returned to its usual shape. If that's too long, then you need to be creating new clusters with, at a lower topic count limit. To allow adding clusters to a data center nearly transparently to messaging clients, we implemented what we called super clusters. It's described in PIP 8 as peer clusters. So if you want to read up on that, you can look up PIP 8 on in GitHub. As I said before, adding storage or publish capacity is as easy as adding more bookies to a cluster. The top graph shows publish rate by tenant, and the bottom graph shows publish rate by bookie. You can see that despite an imbalance of rights, a write throughput per tenant, the rights per bookie is fairly evenly distributed. Achieving the balance doesn't take any effort on our part. It's a result of the Pulsar architecture. And if our tenants were better about using partition topics for a high publish rate topics, the cluster of lines in the lower graph would be even closer together. I want to also call your attention to these lines where the publish rates dropped to 0 and comes up from 0 on the Bookkeeper graph. This is actually where we're taking bookies out of rotation for OS upgrades. So you can see they ramp up to normal traffic just within 10 minutes, despite having been wiped and put back into rotation. So you saw before we had over 100 tenants in the multi-tenant environment. We can onboard so many because provisioning is fairly lightweight and self-service. From their expected traffic numbers, we calculate whether the cluster's brokers and bookies have enough capacity and either automatically provision the tenant or we open a dialogue with them while we expand the cluster's capacity. Once the tenant ID is created, tenants create and manage their own namespaces, topics, and subscriptions using Pulsar admin. We stay hands-off unless we need to change some namespace policy that's reserved for the super user. We generally assume an excess of storage capacity, so we don't provision storage required for backlog for most of our tenants. We do calculate it for the major tenants where we need to add capacity. Then we will do the exercise of how much storage we need for however long they need to retain backlog. The defaults for all of our clusters is no TTL, 50 gigabytes of storage quota per topic with the producer exception policy. We advertise the Pulsar platform within Verizon Media as a reliable messaging system, so we have no default policies which will result in silently dropping messages. If tenants want some other policy, they can use Pulsar admin and change that policy on the namespaces. We use the 50 gigabyte storage quota to catch mistakes, and it's responsible for almost all cases where customers are reporting or tenants are reporting publish failures. Usually it's because they aren't managing some backlog correctly and they run into the storage quota. So those 5 years of operating, they've seen a few major generations of hardware. The broker configurations have pretty much evolved with CPU technology. The pre-2015 spec was sized for the Pulsar predecessor, which had difficulty maxing out even our 1 gig NIC. We found more RAM has been beneficial for keeping JVM GC times acceptable under high throughput, which is why the 2020 spec has so much more RAM. These days, we run a mix of configs from the 2015 through the 2020 spec, and also 8-core 24 gigabyte virtual machines. A heterogeneous cluster of brokers works just fine thanks to the broker load balancer and, when we need to, broker isolation policies. The Bookkeeper hardware configs have evolved with storage technology over the years. Thanks to Bookkeeper's architecture, we're able to make the maximum use of whatever we have it running on at the time. In the pre-2015 config, we used the RAID write-back cache for journal fsyncs and achieved low publish latency that way. We had a few near outages due to running out of storage, so our 2015 spec has larger disks. We didn't actually ask for 40 terabytes of raw storage, but that was the available configuration at the time, so we went with that. We added SSDs for consistently fast fsyncs on the journal, but we still found that those early SSDs had bad 99th or 99.9 percentile fsync latency, so we still had to depend on the hardware RAID write-back cache to smooth out those spikes in latency. So with the 2015 config, we were able to achieve about 100 megabytes per second at 5 milliseconds of 99th percentile publish latency, even while draining backlog. I'm happy that in 2020, we finally got an all-flash config. Like Rajan presented yesterday during his talk on Bookkeeper with PMEM, we're able to achieve 600 megabytes per second with 5 millisecond 99th percentile publish latency on the 2020 config. Unlike brokers, a heterogeneous cluster of bookies doesn't really work well. The Bookkeeper client doesn't weight traffic by bookie capability or available space. So if you have bookies with lower amounts of backlog storage than the rest, they will fill up sooner, they'll go read-only, and then you lose that throughput from your cluster. If you have bookies that have a higher throughput capacity, they won't see any more writes sent their way. The Bookkeeper client just uses, a more or less round robin for distributing writes. There's possibly a workaround for that using Bookkeeper affinity groups, but we haven't tried it because our clusters still are homogeneous. The evolution of Zookeeper hardware is the least exciting. It's very similar to the broker config. In 2015, we added more RAM, and we gave a dedicated SSD for the Zookeeper journal once the snapshots got large enough to need more RAM, and syncing the snapshots to disk was affecting the fsync time for the journal. In 2020, we just got larger, faster SSDs because that's what's available on the market. One of the long-standing struggles we had was JVM GC pauses impacting write latency or publish latency. Pulsar was architected from the beginning for high throughput and low latency. It used Netty for off-heap buffer management from the start as opposed to putting things on the heap. But GC pauses were still a problem and caused incidents. We used G1 GC tuned to produce 100 millisecond pauses every other minute, allowing us to meet a good 99th percentile SLA, but not a decent 99.9 percentile SLA. Still, we had issues where when the heap grew over half full, pauses, the GC pauses occurred more frequently and for longer, and that caused us to miss our SLA. That was a result of how we tuned G1 GC. Improvements were still made to Pulsar over the time, like using shorter-lived objects or recyclable objects. We reused neti buffers for topic and broker stats instead of generating them on the heap every time. I'm afraid I don't have any graphs of Pulsar 1's GC behavior anymore. Pulsar 2 had some improvements. It buffered less. It doesn't cache reads from backlog or from Bookkeeper, backlog reads. And what it did cache had a shorter lifespan. So GC pauses were greatly improved, but we still saw a few instances of long GC pauses. Like you can see in that, we had a few high GC pauses within the span of an hour. That was quite it was an outlier amongst our servers, but we still had some instances of that. I want to note that these GC pause times are on a logarithmic scale. So you can see that even under Pulsar 2, we had a few instances of GC pauses over 1 second. We did finally switch to ZGC, and we've done very little tuning. The only thing we did was we set, I think, the target pause time for 10 milliseconds, or the target GC time for 10 milliseconds. It runs much more frequently, which is the light green line, but it doesn't pause the world. There are still world pausing events from JVM save points, and we didn't have visibility into that before, so now we do. But overall, I'm very happy with ZGC, and I encourage everyone to use it if you aren't already. So the graphs from the previous slide show just one bit of the metrics we collect and even alert on. Verizon Media has a monitoring platform called Yamas. It collects metrics with dimensions, aka tags. It stores them in a time series database for aggregation, for graphing, and for alerting. The Pulsar platform collects lots of metrics. We collect system metrics like CPU, file system, disk, and network utilization. We collect broker metrics from the /admin/metrics endpoint, specifically the managed ledger activity, JVM memory and GC activity, Zookeeper activity. We collect per namespace metrics for all the namespaces running on the broker, message and byte throughputs, latencies, message sizes, replication activity, and producer, consumer, and topic count. But there's lots more metrics available to slice and dice. A topic with just one producer, one subscription, one consumer, and replicated to one other cluster has 25 graphable metrics. If you multiply that by 2.8 million topics and you have fresh metrics every minute, that's too much data to collect, let alone store. And if you use short-lived or dynamic topic names, that explodes the cardinality of the dimension holding topic name. But our tenants want their metrics in detail, right? They want to create graphs and alerts on the topic or subscription level so they can act on them. So our solution was, I created the Pulsar monitor, which was the inspiration for the original Pulsar dashboard. It has a collector process, which is multi-process and multi-threaded Python. That fetches the /admin/destinations output for every broker in an environment. It pushes that into Redis. And then our tenants, using either web browser or server running running a daemon, will interact with that through a Python script, also serving requests through UWSGI. It queries Redis and gives them their metrics. And then we also have another process, which is a topic monitor. So what the topic monitor does, it scans all the data in Redis and it looks for topics or subscriptions with a rate out of 0, even though backlog is present, or it looks for topics with lingering pending add entries. And when it finds those, it sends us an alert to investigate them. So this is the monitor UI. It has a drill down view from the tenant and cluster down to the namespace and topic. You select a tenant and cluster and it lists all the namespaces. You click on a namespace, it lists all the topics. You click on a topic and then for that topic, it shows all the subscriptions and also all of the replication metrics. Like I said before, there's also an interface for daemons to collect metrics. This is just a Python script. It constructs an HTTP call, which functions as a query. So tenants can query these metrics just based on patterns. In this case, the pattern is searching for all subscription metrics given this, with the subscription name subscription1 under this tenant name tenant1, and it's requesting only the backlog and the rate out metrics. So they make this HTTP call, they get their metrics, and then they can submit it into Yamas, from which they can do graphing and they can set alerts and so on. Switching topics a bit here, for deployment, we don't have maintenance windows. Our deployments are like replacing the tire on a car that's driving on the freeway, except our car has 6 wheels, so it's always stable while we're replacing a tire. We still take some care to deploy safely. We make manual reviews of all changes between releases. We give 24 hours to bake between the pre-production clusters and the first set of production clusters, and then between the first set of production clusters and the rest of the production clusters. We also sequence the production cluster deployment, so a tenant can fail out to the other colo in that region or the other data center in that region if there's a problem. We sometimes see issue with Zookeepers on deployments, so we don't deploy those in production with every release. We deploy to 1 host at a time per host type for the fewest topics impacted and least Zookeeper rights associated with deployment. We have pre and post check scripts for each host. The Zookeeper pre-check script will verify that the quorum has half plus 2 Zookeepers online. You can see the post-check script will verify that the Zookeeper server is able to rejoin the quorum. The Bookkeeper pre-check script will verify that there are no under-replicated ledgers already, and it disables auto-recovery. The post-check script, it checks it's listening on the ports. It checks for the /ledgers/available or /ledgers/available/read-only node in Zookeeper to show that the Bookkeeper node has registered itself correctly to be accessible to clients. It runs the Bookkeeper shell bookie-sanity command to verify that that Bookkeeper can accept writes, and then it re-enables auto-recovery for the cluster. The brokers, they don't really have a pre-check script. The post-check script makes sure it's listening on all the ports, and it runs the sanity test to make sure that it can publish successfully. One of the mentions we manage, another way we manage risk is by partitioning multi-tenant clusters using broker isolation policies. We have a few common uses for this. Examples of misbehaving tenants we've seen are tenants who use too large messages or message rates and they end up overloading the NIC on a broker. We've had tenants who create a new producer with every message and then don't close them. So that causes the broker to eventually run out of memory. And then that follows the topic from broker to broker. We've had issues, well, we've had instances where we've had some tenants who have very large numbers of individually deleted message ranges, causing a lot of work for the GC and causing GC pauses. Some instances we've had where we've had to use isolation for debugging purposes was the first production user of non-persistent topics discovered a few deadlocks. So we isolated, that tenant to their own brokers. We've had instances where a tenant with large messages and many connected consumers expose some issue with netty buffer tracking issues. The use of isolation groups lets us also tweak settings when we discover an issue and possibly deploy patches to just to those isolated brokers to see if that fixes the problem before we make a wider release with that same change. Pulsar 2 introduced something called failure domains and anti-affinity groups. I think that's better, but I haven't actually tried using it yet, so we're still sticking with isolation policies for now. I mentioned before in the Bookkeeper hardware slide, we've had some near outages due to running out of storage. So these were caused by the last 3 bullets on this list, which are a little bit more subtle in terms of how they impact Bookkeeper storage utilization. The second bullet there, increasing the write quorum. can have a pretty drastic impact. So increasing the write quorum from 2 to 3 might seem like a good idea for fault tolerance and latency purposes, but that one change is going to use 50% more disk storage across your entire cluster. Over-replication, the third from the bottom, is a factor when ledgers are long-lived and you take Bookkeepers down long enough for auto-recovery to replicate all of its ledgers and then bring it back into rotation without wiping it. The Bookkeeper Garbage Collector and Compactor won't compact ledgers unless those ledgers are deleted, regardless of whether that bookie is referenced in the ledger metadata. There is an over-replication cleanup function to clean up ledgers in that circumstance, but we leave it disabled because it puts a lot of write load on Zookeeper. The second from the bottom here, the rollover times, that's a factor because ledgers that are open for writing won't be deleted by the broker, so they don't become eligible for garbage collection or compaction. If your rollover times are high enough and you have enough topics open for writing, you can actually fill up your Bookkeepers with open ledgers. The current default in Pulsar are the result of our painful experience, so don't increase those unless you know what you're doing. Conversely, you can actually decrease those times, but it means more writes to Zookeeper in the steady state of operation. So crossing Bookkeeper compaction thresholds, it's really hard to predict, but it is something to keep in mind. So what that means is if you onboard some new tenant and their ledgers have a lifespan that's just a little bit longer than everybody else's, and their ledger lifespan is longer than your minor compaction threshold, then the addition of their ledgers, mixed in with everybody else means suddenly your entry logs, they have live data that exceeds the threshold of the minor compaction. What that means then is minor compaction won't find any work to do, and now you need to suddenly be able to store all of the writes that occur between major compaction intervals, whereas before, you got to reclaim some disk space with every minor compaction. So the rack awareness is another way we handle failures and give us some resiliency to failure. So we consider a rack to be the largest common unit of failure or maintenance we're expected to withstand while still serving traffic. Using the rack aware policy, we can maintain service despite losing all of the bookies on a rack. There's two ways you can kind of handle rack awareness. If you have n physical racks, you can arrange them either into 2 logical racks or n logical racks. If you have 2 logical racks, you actually get a greater chance of tolerating the loss of 2 physical racks. You're going to survive the loss of 1 physical rack in either case, but if you use 2 logical racks, you have a chance of surviving 2. For example, if you lose this first rack here, then you've lost access to 1 copy of ledgers A and D. Now, if you lose this rack here, then you've lost access to both you'd haven't lost. So if you lose that rack there, you're still, sorry. If you lose that rack there, then you still have access to all of your ledgers. But if you lose this rack, then you lost access to both copies of ledger A. So you've got basically a 50-50 chance of a 2-rack failure causing ledgers to become unavailable. On the other hand, if you use a n logical rack configuration, then you'll survive your loss of your first rack. But then if you lose any other rack, you're going to have some ledgers to become unavailable. In this case, we lose access to ledger E. If it wasn't this rack that failed, but this one, you've lost access to ledger A. So your chances are you're going to have ledgers that span any 2 bookies. So if you use an n logical rack configuration, your chance of losing access to some ledgers with losing 2 physical racks is 100%. So the downside to using a 2 logical rack policy is you need to provision more spare capacity, because when you lose a physical rack, the traffic no longer has n-1 racks to redistribute to, but n divided by 2 minus 1. That's it for the prepared content. I hope you got something useful out of my 5 years of experience condensed into 27 minutes. Thank you for listening.
Thank you. Thank you, Ludwig. So let's take a look here. So folks, that was awesome. Folks, if you have any questions, you'll see a little box at the bottom of your screen that just says Q&A. Just type your questions in there and we'll be happy to have Ludwig or Joe answer them. Let's see here. So Ludwig, I actually have a question. You know, you've been on the Pulsar team, and Joe, you as well, for many, many years now. I've noticed there's a lot of folks attending who are very new to the community. What recommendations do you have for them to sort of get involved, start using Pulsar, and start contributing? Because there's just a lot of interest I noticed, you know, even yesterday. What are your recommendations since you've been here from the early days?
I'll let Joe handle this one.
Joe's been here since early. Oh, and Joe, you're on mute, I think. Yep, let's see here, yeah. All right, let's see.
Yeah.
Okay, yep, perfect. Yeah, any advice?
It's a much simpler system to, you know, operate and scale up. You know, even though there is like, you know, there is a separate broker at Bookie, you could probably do much more through a set of nodes than, you know, any other questions. So in terms of scalability, right, we don't really do any manual operations. We just add, you know, hardware, right? That's all we do. And in terms of, you know, operational complexity itself, right, we don't get involved in, you know, tenants doing stuff, right? We just provision tenants based on hardware needs. We just provision storage, bandwidth, and compute. That's it, right?
And Joe, we got a lot of questions coming in right now. The screen is lighting up, and we've only got maybe 4 minutes. So Joe, do you and, you know, Ludwig want to take a quick look? A lot of questions.
Okay. So for the first question here, what's our experience of operating Pulsar compared to other messaging systems such as Kafka? So I haven't had to operate Kafka at Verizon Media. Joe has had a lot of talks with other tenants at Verizon Media, so you can share.
Let me take that. So we are moving some of the large, you know, use cases from Kafka to Pulsar, and, you know, we're not forcing anyone to move. It's like when it comes time to refresh the stack, buy new hardware, you know, they take a look at, you know, the choices, you know, what's the dollar amount they have to spend and what's the operational complexity they have to invest in, and they make the choice. So far, people are choosing Pulsar, which is good.
Okay. I can answer this next one here. How do GC pauses affect your SLAs when you have multiple brokers and bookies serving a topic? Well, like I mentioned before, yeah, we were able to achieve our 99th percentile SLA in most cases, even under G1 GC, because we basically expected to have one bad pause event per 2 minutes, which lets us meet 99th percentile. With ZGC, right, the GC pauses are a lot more consistent and they're a lot smaller because now the only pauses we really have are the JVM safe points. And I think they average to be less than 1 millisecond per pause. So I would say they don't really affect our SLAs anymore. They bring, I would say they bring our average published latency up by a tiny bit just because now we have so many small pauses. Well, we probably had so many small pauses before, but we didn't have the visibility, but now we can see exactly how many safe point pauses we have. So yeah, I would say GC pauses don't really affect the SLA. Bookkeeper GC pause, I don't think we've ever really had an issue with that. It's always been, yeah, we have alerts set for it, but we never get any alerts for it. So Bookkeeper GC pause isn't really a factor. Next question here, is Verizon's Pulsar deployment purely on-prem?
Let me take that. So
okay.
Yes, at this point, Verizon Media's deployment is purely on-prem, but our mother company, Verizon, does have you know, Pulsar installations running in AWS. And we are planning to hook up, you know, both of them together, you know, because it's very simple with Pulsar to replicate between 2 data centers or between AWS and, you know, our data centers. It's just a configuration that you just need to, you know, configure, you know, 2 cluster URLs into clusters, and they can replicate data between each other securely and reliably. So we do have Verizon operating, Pulsar in AWS. Not us, we are Verizon Media.
Would you recommend running Bookie on a node with a single hard drive? What if we were to disable fsync?
So let me answer that too. So the premise of Pulsar is reliable message delivery, guaranteed delivery, and you should understand that you're breaking that promise once you do that. Actually, you should talk to Matteo, from Pulsar, Apache. He's working with Splunk now. They have actually disabled the journal and run Pulsar for where they don't need reliable use cases. So it's definitely possible, but then you should also understand that at this point you don't have guaranteed delivery anymore. I know Kafka runs similar to this, but we have use cases that demand reliable delivery. That means when a message gets published and we acknowledge to the publisher, hey, it's published, we guarantee delivery.
All right, so that was fantastic. We're going to need to wrap here because we'll soon be joined by Jesse Anderson for Pulsar for Kafka People. Joe, Ludwig, where can folks learn more? I know that you're going to be, Joe, will there be an additional blog post about this? Where can folks learn more or connect with you? Is email the best? Is LinkedIn better? What do you recommend?
Yeah, so I'm available both on email and LinkedIn, and Ludwig.
I prefer email.
Cool. All right. Well, I'm going to go ahead real quick and stop recording. But before I do, I just wanted to clap, 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 because that was fantastic. And thank you both for all you do as far as contributions and for the community. So thank you both so much.
Thank you.